Hello students, this is Dr. G. Savita, your teacher, Department of Chemistry, Maharani Science College for Women, Mysore. Hope you are safe at home. And now onwards we are going to start with your third semester, that is your second year. And we are going to start with your organic chemistry, the first chapter being the alcohols. And in this video, I will be defining what are the alcohols and explaining its classification. So we know very well in organic chemistry we have a functional group which is going to determine the properties. We have classified the functional group. We have dealt in detail in the first semester. Among the functional group, the OH group is also a functional group. So let us define what are alcohols. So an alcohol is any organic compound in which a hydroxyl functional group is bound to a carbon atom and usually connected to other carbon or the hydrogen. So in our organic compound, if we have the functional group OH attached to a carbon along with the hydrogen, then those group of compounds we define them to be alcohols. Is it clear? So once again I give the technical definition. Alcohols are those organic compounds which are characterized by the presence of the OH group attached to a carbon atom, which are in turn attached to carbon or hydrogen atom. So a few examples for your alcohols. The first and the simplest is the methanol, where the hydroxyl group is attached to one of the carbon atom, and since this primary carbon atom has only one, we have the parent name as methane, and O is the IPAC nomenclature for your alcohols, and hence I call this to be methanol. Likewise, when it is attached to a ether, we call it to be ethanol, and if it is attached to a propane, the three-member carbon atom, we call it to be propanol. So these are a few examples for the saturated alcohols. And now once again when we go back to your alcohols, these alcohols we can also consider them to be the organic derivatives of water. Why I have quoted this? We know the water molecule HOH. So in your water molecule, if I am going to replace the hydrogen by an alkyl group, then we get the alcohol. So the ROH is the general formula for the alcohol. I hope the definition of alcohol is clear for everybody. So like you have a saturated carbon atom to which you have the functional group, we can also have an unsaturated hydrocarbon to which you have the functional group. So we can have an unsaturation which may be a double bond, or we can have an unsaturation which is a triple bond. So we will deal with the unsaturated alkynyl and alkynyl a bit later, and 2-propanol is an example for an unsaturated with a double bond, and 2-propyne all is for a triple bond. I hope for everybody the definition is clear. So moving to the next, as I already defined, in your alcohol we can have the general formula CnH2n plus 1 hydroxyl group. In a simple manner, I can represent the alcohol as ROH. R is an alkyl group. So, and when I take your general formula, as we all know, the N can be 1, 2, 3 and so on. So, it's very clear, I think, for you students, the definition of your alcohol, and I have given a few examples which can be a methanol or your ethanol. In further slides, we will be looking at many more examples. As we know very well, in any of your organic compound, basically we'll be dividing the functional group based on the nature of the hydrocarbon chain to be aliphatic and aromatic. We know what are your aliphatic. If I have a straight chain hydrocarbon, I call those group of organic compound to be aliphatic. And as we have already discussed, this aliphatic can be saturated without any double bond. Example, methanol, ethanol, etc. And unsaturated can be a double or a triple, propanol or propyl. So next we go for the aromatic. So we know what is an aromatic. In your second semester, we have come across the concept of your aromatic, where a set of characteristic features will define the property of aromatic. We will be taking your aromatic alcohols a bit later. Let us go for your unsaturated. So in your unsaturated alcohols, we can have your two types, allylic or vinylic. So if you just look at the structural formula which I have written here, you can easily identify the difference between the allylic and vinylic. So when I take your allylic unsaturated alcohol, so this is your carbon atom which has your functional group. Kindly note here, students, here the carbon carrying the hydroxyl group does not have the double bond, but the carbon which is attached to this carbon have a double bond. So the unsaturation is not directly linked to your functional group. Such group of unsaturated, we call them as allylic alcohol. So in the second classification of your unsaturated, if you just look here, this is your carbon atom with your functional group, and the carbon which has the functional group as also an unsaturated. Such a functional group, carbon with the functional group as well as a double bond or your unsaturation, we define them to be vinylic alcohol. Is it clear? So next we move on to your aromatic alcohol. So I have already told you in your second semester, we have defined what are the characteristic feature your organic compound should have to be an aromatic. And generally we always have a notion, a benzene, a cyclate with 6 carbon atom with an alternate and a double bond, we represent to be an aromatic. To such an aromatic compound, whenever we have the functional group, we call the respective aromatic compound. Is it clear? So now I like to define your aromatic alcohol. So when you take your aromatic alcohol, we have a general notion, OH, the functional group, will be directly attached to your benzene ring. Students, note here, when we have a OH directly attached to a benzene, we don't consider them as to be an aromatic alcohol, but we call or we give them as phenols. So where the functional group OH is directly attached to your benzene ring. But when I want to represent them to be an aromatic alcohol, here the functional group OH is attached through a side chain. Is it clear? When the functional group is attached through a side chain to a benzene, we consider this organic compound to be aromatic alcohol. And one of the simple example is your benzyl alcohol. So in this slide, we have looked what is the general formula. And one more thing I have to say here, we have your sp3 hybridization. We know very well whenever we have a sp3, it is a tetrahedral, and we will look at the structure of your alcohol in the upcoming slides. Okay, now we have classified your alcohols to aliphatic, aromatic, and once again your unsaturated to allylic and vinylic. And we have defined what are your aromatic, and we have also looked at a simple example, that is your benzyl alcohol. Moving to the next slide, these are a few examples for your aliphatic alcohol, methanol, its structural formula, and it's your formula, structural formula, and your displayed formula. So if I have one carbon atom, we call it to be methanol, 2 we represent to be ethanol, 3 we call them to be a propanol, and when I have a 4 carbon atom, we call them to a butanol. And these are your displayed formula of your different examples of your saturated aliphatic alcohol. Is it clear? Next, I'll take a 3 member. Here it is saturated. We call them as propanol. So here we have a double bond. So we call it to be 2-propanol, and we have a triple bond, 2-propyl. These are the few examples for your aliphatic alcohol. So coming to the next part, that is your structure. So we know in your alcohol, we have a functional group, that is your OH. And here in your OH, we have your oxygen and a hydrogen. So when I take the oxygen of your OH group, this is OH group is attached to your carbon by a sigma bond, that is a direct overlap of your bonding. And as we all know well, it is an sp3 hybridized orbital of your carbon, and it is going to overlap with the sp3 hybridized orbital of oxygen. And when we go for your sp3, it is a very clear, we know the structure would be a tetrahedral angle with a bond angle of 109 degree 46 minutes. But here there is a slight decline in the bond angle when compared to the bond angle in the regular tetrahedral. So we know very well the oxygen which is bonded to your carbon have 2 lone pair of electrons. This lone pair of electron, because of your repulsion, there is a slight decrease in the bond angle, and the bond angle once again also depends on the type of alkyl group. So we'll be not going to in detail. So in the next slide, we'll go for if you just list out a few uses of alcohol. So we know very well your alcohols are mainly consumed as beverages, and we have different which we are not going to discuss. Coming to its application with reference to your organic chemistry, some of your alcohols which will be coming in the upcoming videos are used as an anti-freezing agent, and it's also used as antiseptic. And now we know very well the regular petrol, which is one of your fuels, has been replaced by your alcohol. In a similar way, we have lots of applications of this alcohol in the field of medicine, and a few alcohol and its are also used as a preservative for the specimens in the laboratory. So in this whole video, we have just defined what are your alcohol, what is the structure of your alcohol, and we have looked into a few application or the uses of the alcohol. In the second video, I'll be concentrating on the classification of alcohol.